on electric circuit and also the vertical motion. And then we should wrap up the chapter. Okay. So I believe majority of you comes from electric, right? Electronic. So now this differential equation can also be applied on electric circuit, okay, RC circuit. Okay, so as you can see here, given the differential equation of an RL circuit is L di dt plus Ri equals to Et there. So what is the type of the differential equation given that? Anyone? What is the type of this differential equation?
Linear.
Okay, it is linear. All right, so in linear, what are the general form of linear? You should have what? You should check the coefficient, the function with the dependent variable, right? And then the function on the right hand side. So now you have L di dt plus Ri equals to Et, where L is your inductance, all right? R is resistance. E is voltage source, okay, and I is current. So we are going to solve this differential equation in order to find the value of I there, okay? So before that, what you need to justify here is, since this is linear, then you should have the coefficient of differential that equals to 1. Means that you need to divide everything with L. Okay, so you should have this as your linear differential equation. Okay, next, let's take a look at this. So for this case, for this application, we are going to consider two cases. Okay, the first one where the voltage source here is a constant, just a value that is E naught. Okay, and then the second part, the second case, that voltage source is in terms of function sine omega t or cos omega t. So for this case, we are going to proceed with solving the linear equation by looking at the function at the right hand side. Either it is a constant or it is a function of sine omega t or cos omega t. We need to integrate, right? Remember, we need to integrate at the end of the process in order to find what is the solution of the differential equation. But for this case, the solution for the differential equation here is to solve for IT, okay? The current at a given time t, okay? Now, let's take a look at case by case here. So first, case 1, okay, where E T is a constant, right? So solving this, you should identify your PT and QT. Okay, this is your PT and the QT is E naught over L, right? Where ET there is E naught. Okay, so you should have what? You should have your integrating factor. What is your integrating factor here? Exponent to the power of integrate R over L with respect to T. So you should have exponent to the power of R over L T. Okay, so these are all given in the notes. Okay, and then for the solution, you should just put mu t times with I equals to integrate mu t times with pt with respect to t. All right. So this one you should have integrate exponent r over lt times with e naught over l. This is a constant. Okay. And mu is exponent r over l times with I. Right? Clear? So solving this, you can have your I. Right? I equals to, by looking at your notes, E naught over R plus CE minus R over LT. Just solving the integration process, simplify and factorize to get the value of I there. It is easy for this case because we have E naught as a constant, as a value, right? But for the next case, your voltage source is in terms of function. It is also doable, but you need to apply the integration by part or integration by tabular method. Same process, right? So look at case 2. Let's say your ET in terms of E naught sine omega t. Okay, by looking at the general form here, your di dt should be di dt plus r over li equals to E naught over L sine omega. So the difference here is, this is in terms of constant, this is in terms of function of sine omega t. So this is your QT and this is your PT. Same with the previous one. You should have your what? You should have your integrating factor equals to exponent to the power of R over LT, right? Then substituting to this, you will have exponent R to the R over LT times with I equals to integrate exponent R over LT times with E naught over L sine omega t. So the process here is you need to integrate this by part or by tabular method, which I believe all of you have learned this. All right? Is that clear, everyone? For case A and case 1 or and case 2. All right, anyone has question? Okay, so next try to take a look at the example. Okay, look at example 1 here. So we have two 9-volt batteries, okay, are connected to a series in which the inductance is 0.25 and the resistance is 8 ohms, right? And then determine the current I if the initial current is 0. Then determine I when t approach to infinity, where it is in steady state. So now identify the information given. What is the two 9-volt batteries here? 18 volt is what? What is the value for? Okay, for E naught, right? This is your E naught. Okay, and then inductance is 0.25 is what?
L.
Okay, L 0.25 and the resistance R, right? Determine the current IT if the initial current is 0. What is the meaning by initial current is 0? We want to find IT, okay? And the given condition is the initial current is 0. What is the meaning by this? Come on. Anyone? Initial current is 0, means I equals to 0. What about T?
Zero.
Yes, okay. So the given condition is I naught equals to 0. When T equals to 0, I equals to 0. Then in order to find I, we need to identify I by using the differential equation of electric circuit. Right? This one, right? Or I, sorry. Okay. And we have simplified this in terms of linear. We have the IDT plus R over Li equals to E naught. So just substitute everything. We have the IDT, R is A, L is 0.25 I, and E naught is 18. Okay, so from here, identify your P, identify your Q, okay, integrating factor and solve the equation. Okay, try it. If you have question, you can ask. What is your integrating factor? Okay, this is 32. QT is 72. Okay, thank you. Then mu t integrating factor is exponent to the power of 32t. And then integrate mu t and qt in order to get I, and then apply the condition, and then solve the equation of I, and then determine I when t approach infinity. All right. All right, so look at the chat here. We have the answer. Okay, so you have your IT equals to 9 over 4 exponent 3 over 2t plus with A, and A is minus 9/4. Okay, when t approach to infinity, just substitute t here with infinity, and then you should have I equals to 9/4, which is 2.25. Okay. All right. Clear, everyone?
Doctor, may I ask a question?
Yes.
From the LDIDT, the equation, we divide all the terms by L, right?
Yeah, yes. Oh, this one is L.
Okay. Thank you, doctor.
So this one also 0.25. Okay, thank you. All right, anyone has question? Okay, no question? All right. So let's take a look at the next example. Okay, now we have considered the circuit given in the figure with R equals to 4, L equals to 2, V equals to cos 3t. Find the current. Okay, so still we are in this electric circuit RC. So in order to find the current, you need to solve this differential equation. All right. So we are going to use the same model for this current circuit, for this RC circuit. Then we have here dIdt plus R over Li equals to E naught over L. Right? And then this is case 2 where your voltage source is in terms of cosine. Okay, the given voltage here in terms of cos 3t. So just substitute everything here. We have the IDT. R is 4, L is 2, which is 2i equals to cos 3t over 2. Okay, in order to find I, so identify your PT first and then QT. Okay, and then obtain your integrating factor and then solve for I. Okay, can you do this? QT. Okay, try to do this. If you have question, you can ask. The answer is, try it first. There is no condition given, so you should have a constant in the solution. Okay, so next application is vertical motion, right? Following Newton's second law of motion. Okay, so the Newton's second law of motion is given by this. M dv dt equals to F. And you remember what is the change of velocity within time? You know that? What is the change of velocity with time here?
Acceleration.
Acceleration, right? That's why you have F equals to ma, right? You use this in your physics, right? All right, force equals to mass times acceleration. So this Newton's second law of motion comes from this m dv dt equals to F. All right, how much an object accelerates depends on the mass of the object and how much force is applied to it. All right, so you know that F is the external force, m is the mass, v is the velocity, and t is the time. Okay, so there are many types of forces there. So we have here gravity, normal forces, tension, and friction, right? Okay, now let's take a look at the example. Okay, before that, what is the type of this differential equation?
Separable.
Okay, so it is separable equation. So now let's take a look at this. A parachute is falling towards us, okay, with a velocity v. So his acceleration is given by this. Assume that the parachute starts from rest, right? Rest when t equals to 0, okay, v equals to 0. Find the velocity vt and the distance xt that the parachute has fallen after t seconds. So this is given by dv dt, and you know that this comes from the vertical motion where the general form follow exactly the separable equation. So you just need to separate this. Okay, separate this, you get what? Sixteen minus 3 equals to 3, right? And you just can also bring everything, right? 1 over 32 minus 2v with respect to v, and then we have, then you can integrate both, same. Okay, so this one you can get what? Minus 1 over 2 ln 32 minus 2v equals to t plus c. Same, if you use this or simplified like Theo did in the chat box, okay? You just bring that 2 to the right hand side and then you get negative 2 there. Okay? And then solving this in order to get v, what is your v? Okay, first this one should be 32 minus 2v equals to exponent negative 2t minus 2c. Right? And you will have here two v equals to 32 minus exponent minus 2t. Okay, this comes from this one, where a here is exponent negative 2c. All right, and then v equals to 16 minus a over 2 will give you b, another constant. Okay, then you can simplify by using this. So this is the general solution of v. All right, so applying the initial condition, when t equals to 0, v equals to 0, then you get v equals to 16. Okay? And then your vt equals to 16 minus 16 exponent minus 2t will give you 16, 1 minus exponent minus 2t. All right? So now this is your v. And then you want to find distance. How can you find distance? X. How can you find x? Yes, you need to integrate v to get c because velocity is equals to what? Distance over time. Change between distance over time. So in order to get x, okay, velocity equals to change between distance and time. So in order to get x, you have to integrate v. Then you can get x. Okay, so now you just integrate v. Then you can have your xt. Okay. And apply the same condition from rest t equals to 0, v equals to 0 means that x also equals to 0. So you have the condition x is 0 when t is 0 because v is 0. So c equals to negative 8 and you have your x 16t plus 8 exponent minus 2t minus with 8. Okay, this is how you solve. Any question? Understand or not? Okay, good, clear. So now I'm going to leave you with example 2. Okay, with example 2 here. Right, try to finish this and then submit through the activity in the e-learning. So I just can briefly explain here first. All right, a particle move vertically under the force of gravity G against air resistance. So this is the condition of the particle moving. Okay, and if the particle starts off from rest, means that t is 0, v is 0. Show that your v is obtained by this equation where lambda there is set of g over k. So this is just showing process, and then find the velocity as the time approach infinity. Okay, so the answer is v equals to lambda. Okay, try to prove this, right, and submit to the activity in the e-learning. Okay, so now basically we have done with this chapter. Okay, so we start with understanding the terminologies, independent and dependent variable, the order, the degree, the linearity, the condition. We have IVP, BVP, and then there are two types of solution, general solution and particular solution. And then we know that there are two types of differential equation, ODE and PDE. And what we have been doing in chapter 1 is now ODE, okay? And we have discussed 5 types of ODE: separable, homogeneous, exact, linear, and Bernoulli. Okay, and then we have also discussed 4 types of application: law of cooling, growth and decay, electric circuit, and motion. And actually, there are many types of differential equation and there are many types of application outside. So we have discussed some of it. All right. So basically, these are all from chapter 1. Okay, you can proceed with the tutorial after this. Okay, and then try to do the activities given in the e-learning. Okay, is there any question for chapter 1 from 1 to 10? Where are your understanding? Sometimes it's given, sometimes you need to understand the problem given. But usually it is in terms of this 4 application only. this one, because we have discussed this application. Okay. No more question?